Okay, so lesson 6 is going to be a refresher. It's going to be a refresher from past grades. So let's go and calculate the distance formula. The distance formula for any point P1, P2. So for any line P1 going to P2, basically the distance for P1 to P2 is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's it. Now, the midpoint formula. Is given by this definition. The midpoint of the line P1 to P2 is just the average of the x's and the y's for the new point. So you got x1 plus x2 over 2 and y1 plus y2 over 2 being those 2 points. And that's it. Okay, so the reason why this is a refresher is it allows us to understand how to graph and practice midpoint and distance. Okay, so for this graph here, you notice it says sketch what this looks like. And what I'm asking you for is to tell me what this looks like on the XY axis. Okay, now you'll notice you have x being less than or equal to 2 here, but greater than or equal to 1. So what I tend to do is I will go and draw where 1 and 2 are on my x-axis. Okay, you know what? Let's make this nicer. Let's make it 0 to 2. So we're going to go from 0 to 2. So this is saying that my x values for my problem are less than or equal to 2, but greater than or equal to 0. So if I was doing that, I'm basically saying that I'm going from 0 here all the way up to 2. So what I'm going to do for this problem here is I'm going to draw a vertical line. And notice it's a solid line here. A solid line, and that solid line indicates where my boundary is. It goes from x equals 0, which is the vertical axis, all the way up to 2. Now, in order to indicate which side of the line you're using, what you do is you draw a little shaded part on your line. Now, what this allows us to do, it allows us to kind of single out the regions that we're using for our graph. So now, if I'm looking at this next problem here, I'm going to start this in blue. So I'm going to say, remember, the absolute value of y is equal to 1. Now, when does that happen? That only happens when y is equal to plus or minus 1. So there's only one possibility for it. So here's what we're looking for. We are looking for the y values where we have 1 and negative 1. Now, the only time both of these occur is when we have this line that goes directly across here. Okay. Now, that doesn't mean that that shaded region of red that we have there is invalid. It just means that if it said y was less than 1, it would have been a combination of those two to make that shaded region that we have here. But instead of that, what we have is this. We're basically getting all of the points that go from y equals -1 all the way out to 2, so we end up with that, just two horizontal lines. Take a moment and copy that, and we'll move on to the next problem. So for example 2, what I'd like you to do is I'd like you to sketch the following. All right, suppose I have xy is less than 0. Now, here's what we know. For x and y to be 0, their signs for x and y must be different. For x and y. So here's what happens. If x is greater than 0, oh boy. If x is greater than 0, that means y must be less than 0 for our equation here, xy to be less than 0. So here's what we would do to draw that. Here is our Cartesian coordinate plane. We look for values where x is greater than 0. X is greater than 0 for all points that are x greater than 0. So that means everything on this side of the y-axis. Okay? So now, if I want y to be less than 0, these are all the points that are below the y-axis. Okay? And that is all of these points here. So all we're looking for is the intersection of those 2 points, the intersection of those 2 shaded regions. So I've noticed that when I erase that other stuff, we end up with this region as our values for which if x is greater than 0, y must be greater than 0. That's 1. So now, if we do the same analysis again, if x is less than 0, y is greater than 0, then doing the same analysis again, we get the other half of this, and that means we end up with this side of our graph. And we're done. And so now let's move on to the next problem. This problem is especially tricky. The easy part is finding the midpoint of BC. So I'll quickly show you how to do that. And then what we'll do is find the length of A, B, and C. And I'll show you how to do one and then quickly show you the results of the others. And you fill out the work for the other stuff that we have there for part B. So when we calculate the midpoint of BC, all we do is take a look at B and C and just add up all of and average the x's and the y's. So we're going to get -4 plus 4 divided by 2 and -1 plus 5 divided by 2. So we end up with 0 and simplifies to 2. There's our first answer for our midpoint. So now we're going to use, for B, we're going to find out if something is a right triangle. So the key idea is this. Remember that C squared is equal to A squared plus B squared for a right triangle. So what we have to do is we have to find the length of AB and the length of BC and then the length of, so we need to find the length of A to B. Then we need to find the length of B to C. And then we need to find the length of C to A. So your triangle looks like this. You're hoping A, B, C, or it could be CBA, but we're going to use the cycle to help us determine those lengths. So I'm going to show you the calculation for the distance of AB. Then you'll have to calculate the distance of BC and then the distance of CA. All right, so the distance of AB is going to equal the basic equation, right? So remember the basic equation is x2 minus x1 squared plus y2 minus y1 squared, which is equal to the square root of the following. Well, we have -4 minus 7 squared plus -1 minus 1 squared. Punching that in, you're going to get the square root of 121 plus 4, which is equal to the square root of 125. Okay? So now we end up with this. Punching that into your calculator, you're going to get BC equaling 10. And now we'll calculate AC. And so now we'll move on to AC. You'll do your calculation for AC. And you're going to find that your final answer is the square root of 25. Which gives us 5. So you know the following. You've got the lengths of all of the sides of your triangle, right? So you have the square root of 125, you have the square root of 10, and you have the square root, and you have 5 here. Okay? We don't know if this is a right angle triangle, but we do know that C squared equals A squared plus B squared, i.e. the longest side has to equal, the longest side squared has got to equal the square of the two legs of the triangle. If this is true, then square root of 125 squared is going to equal 5 squared plus 10 squared. Oh, look at that. 125 is equal to 125.